Hi guys, so today we'll be solving this problem called construct target array with multiple sums. Uh, let's solve it. Given an array integer target from a starting array A consisting of all ones, you may perform the following procedures. Let x be the sum of all elements currently in your array. Choose index 1 I such that I is between 0 and target size. Set the value of A at index I to x. You may repeat the procedure as many times as you need. Return true if it is possible to construct the target array from A, otherwise return false. So what we'll be doing in this problem is that we have a array of size, uh, whatever the size of the target array is. So the array is initialized to 1 in the start, and we need to identify if it is possible to make that array into the target array which has been given to us. And we can do that by uh, using the sum of all the elements in the array and placing at a particular index and repeating that procedure many times to know how if it is possible to get the target array. So I'll not be using that procedure because by doing that it gives us a TLE. So I'll be following another approach which I'll be coding and I'll be explaining along. So what I'll be doing is that I'll first take all the sum of elements which are there in the target array. Okay. So for int num in target sum plus all the sums of the elements. Then I'll also be creating a priority queue, priority queue. So this priority queue is a max heap as it is default in C++. And I'll be pushing all the elements in that priority queue. Now, why am I doing this? I'll explain in a bit. Now, let me just tell you how we are going to approach this problem. So first, we are going to check if pq.top is not equal to 1. Okay. So what we'll do is we'll follow a bottom, okay, uh, a top-down approach rather than going from 1, which is initial, which is bottom, to above to the target. We'll be coming from the target to the bottom. So for that, we'll be using a priority queue to store the sum of store the number of elements which are there in the target, and whichever is the maximum element comes on the top. So why am I doing that? I'll explain in a second. So I'll first store num uh, pq.top in num, and then pq.pop the maximum elements from the heap that is removed. Now I do sum minus num. I check if sum if oh sorry if num is less than or equal to sum, or sum is less than 1, then we return false. Okay. Then what we do is that we do sum is equal to num is equal to num percent modulus sum, and pq dot push num again, and then we return true outside the loop. Now what we are doing is we are performing certain operations. So first is that we are removing the maximum element from the top of the priority queue. And then we are deleting it from the sum, and then we are checking if num is less than equal to the sum, which is if the removed element is less than equal to the number of the sum of elements, then we return false, because we know that if the particular element is greater than it's if it's greater than if it's less than equal to the sum, then it is not possible to get us the initial array. And if sum is less than 1, then obviously it can't be negative. So that is done. Then we check if num is equal to num percent sum, which is the num is not as greater as great as bigger as the sum, and then we push the num in the priority queue. And this is what we repeat again and again till the time we get one. So that is what we are doing here. We're following a top down approach, and let's run the code to see if everything is working fine. There are no bugs. Okay. Mm, false. Okay. Okay, we need to identify. Okay, so first, what I did was that we had removed sum, right? Num from the maximum element from the sum. So we are checking if that maximum element lies between the lies uh, 0 to the sum. If it is smaller than the sum, then do we return false. Otherwise we check if it is greater than the sum, then we need to bring it to an element which is smaller than the sum. So for that we do num is equal to num percent sum, which is the modulo sum, and then we add the num to the sum, and then we push it back in the priority queue, and this is what we repeat until we get one. So one more thing that we have to do is that we have to create this unsigned, and that should not give us an overflow problem. Yeah, that is accepted. So I hope you guys understood the problem. Do solve it, and you can follow this approach or either solve it by bottom up. So do solve it. Thank you.